To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So in the previous chapter, I completed the lesson Electrochemistry. And I told you all I will discuss the summary in this chapter and then I will carry on with the questions given in your textbook. So if we look at the summary, we will be going through all what we have discussed in the previous chapters. So under electrochemistry, the summary, first one, electrochemical cells are used to convert chemical energy to electrical energy. So electrochemical cells convert chemical energy to electrical energy. That is why from an electrochemical cell, we are able to generate electricity. Now you can remember when you dip zinc and copper into a solution of dilute sulfuric acid, and if you have a bulb connected to it or an ammeter connected to it, you can see the current flow. Because the bulb will light or the ammeter, there will be a deflection. So you know that current is flowing through it. How is that possible? Because of the chemical reaction taking place in the cell. There are electrodes and the solution, and there are oxidation and reduction reactions taking place that give rise to the flow of electrons and therefore a flow of current. So in an electrochemical cell, there is conversion of chemical energy to electrical energy. Chemical energy stored in the chemical substances. When chemical reaction occurs, that energy will be converted to electrical energy. Then a simple cell. So here a simple cell can be made by connecting two different metal rods. They have to be two different metal rods by conductive wires and immersing them in an acid solution. So like I told you all, they have to be two different metals like copper and zinc. Why do they need to be two different? Because one will be more reactive, the other one will be less reactive. And the more reactive metal, for example, if it is zinc and copper, zinc is more reactive. So zinc will dissolve. That will undergo oxidation and will act as the anode. Whereas near the copper, there will be reduction taking place. And that acts as the cathode. And the anode will be the negative electrode, cathode will be the positive electrode. So electrons will flow from anode to cathode and current will flow from cathode to anode in an electrochemical cell. In a simple electrochemical cell, the more reactive metal, so this is what I explained, the more reactive metal acts as the anode and the less reactive metal acts as the cathode. An oxidation half reaction occurs at the anode, while reduction half reaction occurs at the cathode. An anode is the negative terminal, cathode is the positive terminal of an electrochemical cell. And then, you know students, through the external wire or the connecting wire or the external conductor, always electrons flow from negative to positive, while the conventional current flows from positive to negative. Along the external wire, electrons flow from anode to cathode. That is from negative to positive. That is electron flow. This is important. Through the external wire. And the conventional current is considered to flow from positive terminal, that is the cathode, to the negative terminal anode. Then we looked at electrolysis. Electrolysis causes chemical changes in matter by passing an electric current through a solution or liquid. So that is electrolysis. Electrolysis causes chemical changes in matter by passing an electric current through a solution or a liquid. Now there are reactions that cannot take place spontaneously. Now you can remember if it is sodium chloride liquid, you cannot easily get sodium and chloride separated from sodium chloride liquid. So that is a non-spontaneous reaction. But by passing an electric current, we can make that chemical change to take place. And that is what we call as electrolysis or electrolysis. So this is done through a solution or a liquid. In electrolysis, electricity is passed through the solution or a liquid by immersing two carbon or metal electrodes in this. Now here, of course, it is not compulsory to have two different electrodes. They can be the same or different. And also, if it is carbon, then usually carbon and platinum electrodes are known as inert electrodes because they do not react during the electrolysis process. But if it is metals, then of course they can undergo oxidation. So in electrolysis, electricity is passed through the solution or a liquid by immersing two carbon or metal electrodes in it, to which an external electric supply is connected. So you can remember, students, carbon graphite is very much cheaper compared to platinum. That is why, although both of them are inert electrodes, in the lab for our activities we use carbon electrodes or metal electrodes. And when they are connected to the external circuit, what happens? External power supply, the electrode that is connected to the positive terminal becomes the positive electrode. The electrode that is connected to the negative terminal of the external power supply becomes the negative electrode. So here, depending on how we connect the electrodes to the power supply, they become positive or negative electrodes. You can remember that. So then I'll move on to the next slide. You can see the solution or liquid through which electricity is passed is called the electrolyte. So the term electrolyte, the solution or the liquid that can conduct electricity and through which electricity is passed in an electrolytic cell is the electrolyte. To conduct electricity, there should be mobile ions in the electrolyte. So you all know some examples. Aqueous solutions of ionic compounds like sodium chloride solution. Then you can even have the fused or molten ionic compound. Again, sodium chloride liquid is an example. They are good electrolytes because they will have mobile ions. But if you take the sodium chloride solid, that doesn't have mobile ions because ionic compounds in the solid state does not have mobile ions. The same goes for acids. Dilute sulfuric acid, dilute hydrochloric acid. In the aqueous solution, they dissociate completely. Because of that, they also have free or mobile ions. They can conduct electricity well. Same thing for bases. Strong bases usually dissociate in the aqueous solution. So there are free or mobile ions. Because of that, they can conduct electricity well. So those are the solutions. Salt solutions, ionic compounds, solutions or liquids, and then acids and bases. Those are good electrolytes. Since the positive terminal of the electrolytic cell acts as the anode, an oxidation half reaction occurs at the positive terminal. This is different from the electrochemical cell. So you have to remember, positive terminal of the electrolytic cell acts as the anode, and oxidation half reaction occurs at the positive terminal. Why is that? Because the negative ions in the electrolyte solution travel or migrate or get attracted to the positive electrode. And there they lose electrons and get oxidized. So because of that, the positive electrode is the anode. So at the same time, the cations in the solution get attracted and migrate towards the negative electrode. There they take up electrons and get reduced. Therefore, the negative electrode acts as a cathode. Negative electrode is the cathode. Then, manufacturing of useful substances from the products discharged at the electrodes is an industrial application of electrolysis, manufacturing of useful substances. Now, if you remember, when we have fused sodium chloride, when you electrolyze it, near the cathode, sodium liquid is formed, and near the anode, chlorine gas is formed. So, sodium liquid becomes the main product in extraction of sodium, and chlorine gas is the byproduct of extraction of sodium, but both are useful materials. So, that is what is meant here. Industrially, sodium metal is obtained by the electrolysis of fused sodium chloride. Sodium metal is obtained by the electrolysis of fused sodium chloride. Hydrogen and chlorine gases obtained as byproducts of these are also useful chemicals. Here, students, there is a mistake. There is no hydrogen produced during extraction of sodium, because you all can remember we use NaCl liquid. So there is only Na plus ions and Cl minus ions. Na plus is reduced at the cathode, that is what we get as sodium liquid, and Cl minus ions gets oxidized, and that is why we get chlorine gas. There is no hydrogen gas produced. So chlorine gas, that is obtained as byproduct. That I told you. Chlorine gas obtained as byproducts of this is also useful. You can remember bleaching, bleaching of paper, bleaching of pulp, cleaning pools, cleaning water that is used for drinking, water supply, or even bottled water, purifying water. For that they use chlorine gas. Then, subjecting the surface of a metal to a chemical, subjecting the surface of a metal to chemical changes when it is exposed to atmosphere and moisture is known as the corrosion of metal. So, this is the next topic that we discuss. You can see here, subjecting the surface of a metal to chemical changes when it is exposed to atmosphere, that is oxygen, and moisture or water vapor, is known as the corrosion of the metal. So, you can remember magnesium tarnishes, aluminium tarnishes, but there the oxide layers act as protective layers, so they are protected from further corrosion. But when it comes to iron, the corrosion of iron in the presence of oxygen and water is what we call as rusting. There, of course, we have to protect iron from rusting. You can remember that. Subjecting iron and steel to corrosion as above is specifically known as rusting. Subjecting iron and steel to corrosion is known as rusting. Oxygen gas and moisture are two indispensable for the rusting of iron. They are must for rusting, or they are factors essential for rusting. Oxygen and moisture or water vapor. Corrosion of iron is an electrochemical process. So, you are familiar with these reactions. Here you can see this is the oxidation reaction or the anodic reaction. You can see here anodic reaction of this process, that is oxidation of iron, Fe solid becoming Fe2 plus aqueous, losing electrons. So, this is the oxidation of iron. Oxidation of iron. So, that means there should be a reduction reaction as well. That is what we will discuss in the next slide. So, there you can see here the cathodic reaction. Very important. That is the second reaction. The cathodic reaction, that is 2H2O liquid plus O2 gas taking up electrons, 4 electrons becoming 4OH minus aqueous. That is the cathodic reaction. And the overall corrosion reaction can be obtained by the above anodic and cathodic reaction. So, the overall corrosion reaction. So, that is given to you here. water 2H2O liquid plus O2 gas plus 2Fe solid give rise to 2FeOH twice solid. But that gets further oxidized. By further oxidation of FeOH twice, hydrated ferric oxide or rust is formed. Hydrated ferric oxide is Fe2O3.XH2O. Because we don't know the number of water molecules absorbed to the F2O3, we write it as XH2O. That is a hydrated ferric oxide. We do not know the exact number of water molecules present. So because of that, we write it as XH2O. That is rust. And that is a reddish brown color substance, rust. And then the factors that affect rusting. Salts such as sodium chloride, acids speed up rusting. Bases decrease the rate of rusting. We have discussed that using activities. Rusting can be prevented by keeping iron without coming into contact with oxygen and moisture. By keeping iron without coming into contact with oxygen and moisture. These essential conditions for rusting. Both oxygen and moisture are the essential conditions for rusting. So if you can prevent iron from coming into contact with that, you can prevent rusting. So what do? We either paint it, you apply grease, we apply oil, or we coat it with zinc, or we electroplate iron objects. So then it will be protected. For this, iron can be coated with a protective layer of paint, grease, or tin metal. When a metal more reactive than iron is in contact with iron, rusting is reduced because the reactive metal acts as the anode. The reactive metal acts as the anode and iron acts as the cathode. This is called sacrificial protection or cathodic protection. You have to remember that as well. Then galvanizing iron is an example of sacrificial protection. So that is different examples or methods of protecting iron from rusting. You all have to remember all these, students. So that is the summary of this lesson. And in the next slide, I will be discussing the questions given in your textbook. So I'm sure you will do that by yourself first, and then you can listen to my discussion and check your answers. So I'm going to move on to the next slide. So exercise. So like I told you all, students, I'm sure you will answer the questions first and then you will compare your answers with my discussion. So exercise multiple choice questions. You're familiar with these types of questions. When we say multiple choice questions, there are 4 answers. You have to select the most suitable or the correct answer. Sometimes there's only one answer that is exactly correct, direct answer. So then the correct answer. Otherwise, there can be 2 answers that are similar. They are correct, but out of those, one will be the most suitable answer. So you have to select that answer. So under that, the first one. Consider a cell constructed using a zinc metal plate, an iron metal plate, and dilute sulfuric acid. Which of the following statement is true about it? So you should know this cell. Here we have zinc and iron and dilute sulfuric acid as the solution. So this of course is an electrochemical cell. If you had a bulb or an ammeter, you will see the current flow. So this is dilute sulfuric acid, dilute H2SO4, and we have both zinc plate and iron metal plate. Normally you all know, students, when we label the electrodes, we write the more reactive metal on the left side. So this we will label it as the zinc metal and this will be the iron metal. So out of these, now zinc is more reactive, iron is less reactive. So what will happen to zinc? zinc will dissolve. Zinc will undergo oxidation. Zinc solid will become zinc 2 plus, losing 2 electrons. So this is oxidation, and that occurs at the anode. And when zinc loses electrons, it leaves the electrons on the electrode, goes into the solution as zinc 2 plus. From here, zinc 2 plus enters into the solution. Electrons remain on the electrode. Because of that, this becomes the negative electrode. Anode is the negative electrode. And on this side, near iron, what happens? From dilute sulfuric acid, we have H plus, SO4 2 minus, and due to ionization of water to a small extent, again we get H plus and OH minus. So out of these ions, the H plus ions will come near iron and they will take up electrons. 2 H plus ions take up 2 electrons, forming H2 gas. So you will see evolving of gas bubbles near iron electrode, that is hydrogen gas bubbles, and zinc will dissolve. So this is the reduction, and therefore iron is the cathode, and also because hydrogen takes up electrons, it becomes the positive electrode. So that is what happens in this particular electrochemical cell. If we look at the answers, the conventional current of the cell flows from zinc to iron through the wire. So here what happens? Electrons flow from negative to positive. So zinc to iron is electron flow. Zinc to iron, electron flow. So because zinc is negative, zinc to iron will be the electron flow. Therefore, current will flow from iron to zinc. So the conventional current of the cell flows from zinc to iron through the wire. Incorrect. Gas bubbles evolve at the iron electrode. Correct. Iron electrode decays. Incorrect. And iron electrode is the negative terminal of the cell. That is also incorrect because this is the positive terminal of the cell. So out of all the answers, which of the following statement is true about it? It is gas bubbles evolve at the iron electrode. That is the true statement. Is that clear, student? So then we'll move on to the next question. Extra question 2. So here you can see, consider the cell constructed by immersing iron and copper electrodes in dilute sulfuric acid. Which of the following is the anodic reaction? So here, anodic reaction of the cells. Here, of course, I'm not going to draw the cell because you are familiar with this. Iron and copper. Again, you need to consider iron is more reactive, copper is less reactive. So therefore, iron will undergo oxidation, forming Fe2 plus ions, losing 2 electrons. At the same time, near copper, what will happen? When we have dilute sulfuric acid, what are the ions present? Again, H plus, SO4 2 minus, then H plus, OH minus. So here, when iron undergoes oxidation, it becomes the negative electrode and their oxidation takes place. So what happens is the H plus ions go towards the copper electrode and they get reduced there. So near copper, H plus ions take up 2 electrons, forming H2 gas. That is the reduction taking place, and copper becomes the positive electrode. So here, of course, we need to find the anodic reaction. This is the anodic reaction. Anodic reaction. Here, this is the cathodic reaction. Cathodic reaction. So always, students, when you look at a question like this, you have to look at their reactivity. The more reactive metal acts as the anode. It undergoes oxidation. and reduction occurs near the less reactive metal. So that becomes the cathode. So here the question is to find the anodic reaction of the cell. Copper solid becoming copper 2 plus aqueous and losing 2 electrons. That doesn't happen. Fe2 plus aqueous taking up 2 electrons forming Fe solid. That is reduction. That also doesn't happen. Then Fe solid becoming Fe2 plus aqueous losing 2 electrons. That's the correct one. 2H plus aqueous taking up 2 electrons giving H2 gas. That is reduction taking place at cathode. This will occur at the cathode, that is the copper electrode. So the first 1 and 2 do not occur in this particular electrochemical cell. 3 and 4 occurs, but the anodic reaction is the third one. So you need to underline the third answer. Fe solid forms Fe2 plus aqueous releasing 2 electrons. Is that clear, student? So then we'll move on to the next question. So question number 3. Which of the following is an essential factor for corrosion of iron? Essential factor for corrosion of iron. When you say corrosion of iron, recall the reaction, students. Iron will undergo oxidation forming Fe2 plus aqueous and losing 2 electrons. This is oxidation, the anodic reaction. At the same time, 2 water molecules and O2 gas take up 4 electrons forming OH minus ions. That is the reduction reaction. So these are the components that are needed for rusting of iron. So this is iron. Then there are 2 factors, water and oxygen. Those are the factors that are essential for rusting. So if we look at the answers there, water is needed. Atmospheric carbon dioxide is not necessary. Acids and atmospheric carbon dioxide, this is also an acidic gas. You all know CO2 is acidic. That's why when it dissolves in water, we get carbonic acid. So atmospheric carbon dioxide and acids, both are acids. They are factors that increase the rate of rusting. Whereas bases decrease the rate of rusting. But water is the factor that is essential for rusting. So it is water that is essential for corrosion of iron or rusting. Then, if we look at the next question, which of the following is a factor that accelerates corrosion of iron? Factor that accelerates corrosion of iron. Now, atmospheric moisture, it is an essential factor. Atmospheric carbon dioxide, this I told you all, students. So here, if you consider this one, CO2 gas, when it dissolves in water, it gives H2CO3, that is carbonic acid. Carbonic acid. Now this is an acidic gas. So we said that acids accelerate rusting. Earlier also I explained that. So because of that, carbonic acid is also an acid. So carbon dioxide that is present in the atmosphere can accelerate rusting. So here, which of the following is a factor that accelerates corrosion of iron? Atmospheric pressure, moisture, it does not accelerate rusting. It is required for rusting. Atmospheric carbon dioxide gas, yes, it is acidic. Now this is of course an essential factor. Acidic gas. Then lime water. Lime water is calcium hydroxide. That is a base. So grease of course prevents the iron from coming in contact with oxygen and water in the atmosphere. So it actually protects iron from rusting. So grease protects iron from rusting. Iron from rusting. You can remember the methods of protecting iron from corrosion. We discussed that. Applying oil, grease, paint, they all prevent the contact of iron with atmospheric oxygen and water. So out of these, the factor that accelerates corrosion of iron is atmospheric carbon dioxide. It is atmospheric carbon dioxide. That is something you have to remember, students. Then with that, I'll move on to the next one. The fifth question. In which of the following containers are the nails subjected to corrosion? So, are the nails subjected to corrosion? Now, if you look at it, you can see different metals in contact with iron. Iron and copper, iron and zinc, iron and tin, iron and magnesium. So, to answer this question, you all have to know the activity series. So, you can remember, students, in the activity series, we have magnesium, then we have zinc, then we have iron, then tin, and we have copper. So, when iron is in contact with magnesium or zinc, they are more reactive. They act as the anode. These two act as the anode. But tin and copper, if they are in contact with iron, they are less reactive than iron. Because of that, they become the cathode. And iron will rust. So, when in contact with magnesium and zinc, iron is the cathode. Those metals are the anodes. Whereas tin and copper, they become the cathode, iron becomes the anode. So, their iron will rust. So, if we look at the question, which of the following containers are the nails subjected to corrosion? That is when the metals are below iron in the activity series. So, this, there will be rusting, there will be no rusting, or corrosion of iron, there will be corrosion of iron, there will be no corrosion of iron. So, it has to be both A and C. A and C. So, why do we use the word corrosion there? Now, you all can remember, students, rusting of iron is a type of corrosion. That is when iron undergoes reaction with both water and oxygen in the atmosphere. But here, of course, it is corrosion because it's the oxidation and reduction reactions only. So, that is why we can use the term corrosion as well. So, the sixth question. Which of the following statements is not true? You have to look at that carefully. Not true. In an iron spoon, the part smeared with vinegar rust more. Yes. Why? Because vinegar is acetic acid. CH3COOH. So, vinegar is actually acetic acid. Acetic acid. It contains acetic acid. That is CH3COOH. You all are familiar with this, students. So, acids increase the rate of rusting. So, in an iron spoon, parts smeared with vinegar rust more. Galvanized wire rusts when the coating is scratched. Does that happen? What is galvanizing? In galvanizing, zinc is coated. Zinc is coated on iron. So, zinc is less reactive than iron. There you saw that. So, because of that, zinc acts as the cathode. And when it is coated, there are of course no problem. There is no contact of oxygen and water with iron. It will not rust. But when it is scratched also, still zinc is more reactive. Because of that, it becomes the sacrificial electrode and iron is the cathode. So, iron is protected. That is why we call it as the cathodic protection or the sacrificial protection. I am sure you all can remember that. So, this one, galvanized wire rusts when the coating is scratched. That is incorrect or not true. A tin coated vessel rusts when the coating is scratched. That is correct. There you can see tin is less reactive than iron. So when the coating is scratched, obviously tin acts as the cathode, iron acts as the anode, undergoing rusting. So that is correct. I explained this to you all before also. So if you have here, if we have say iron, two objects made of iron, then if we have zinc here, if this is zinc, and here if we have a coating of tin, and this is iron. Here also no rusting, because zinc is less reactive than iron. But when there is a scratch there, it is exposed to both water and oxygen, and tin is less reactive. Tin is less reactive than iron. So because of that, tin acts as the cathode and iron anode. So because of that, it will rust. We have discussed this method. When we did the activity, I explained all this to you all. So you all know, if there is a scratching on the tin coating, because tin is less reactive, it becomes the cathode and iron becomes the anode. Actually, the rusting will be accelerated. So that is, of course, is correct. Then rusting of iron can be prevented by coating it with magnesium. That is correct. Magnesium is also a metal that is above iron in the activity series. So when you coat it, anyway there is no contact of oxygen and water with iron. Even if the coating is scratched, still it will be like this. No rusting. So that statement is also true. So the question is to find the statement that is not true. So galvanized wire rusts when the coating is scratched. That is the statement that is not true. All the other statements are true. Is that clear, student? So when you are given questions like that, you have to always consider the reactivity of metals. So with that, I will move on to the next question. Question number 7. When an aqueous solution of sodium chloride is electrolyzed using carbon electrodes. So this, of course, we will consider the electrolytic cell. So here we have the electrolytic cell, the electrodes, and the power supply. So this is positive, negative, this becomes positive and negative, and these are carbon electrodes. And there it is an aqueous solution of sodium chloride. Here you can see aqueous solution of sodium chloride. So what will happen there? This is NaCl aqueous. So that has ions Na plus aqueous, Cl minus aqueous, then H plus aqueous, and OH minus aqueous. Out of those, you all know H plus is less reactive, therefore it will undergo reduction. You have to consider the activity series there. But when it comes to negative ions, I told you all this before, students, there are many factors that affect what negative ion gets oxidized. We are not going into any of those details, so you have to remember that it is Cl minus ion that will get oxidized. So there what will happen? Since the electrodes are positive and negatively charged due to the connection with the power supply, what will happen? The negative ions migrate towards the positive electrode. So near the positive electrode, Cl minus ions become Cl2 gas losing electrons. So this is oxidation. And the positive electrode is the anode. So here positive electrode is the anode. At the same time, towards the negative electrode, it is the H plus ions. They take up electrons and form H2 gas. There it is reduction, and therefore negative electrode becomes the cathode. So what are the observations there? You see gas bubbles evolving near both positive and negative electrodes. Near the positive electrode, it is chlorine gas. Near the negative electrode, it is hydrogen gas. And what will remain in the solution after that? Na plus and OH minus together, that is caustic soda, sodium hydroxide, will remain in the electrolytic cell. So that is how the electrolysis of aqueous sodium chloride occurs. I am sure you all can remember that. So then, if we look at the question there, what can you see? Hydrogen gas is liberated at the positive electrode. Is that correct? No, because H plus ions migrate towards the negative terminal. So hydrogen gas is evolved or liberated near the negative terminal. This is incorrect. Then sodium hydroxide is formed in the solution. That is correct. That's what I told you. Sodium and hydroxide ions remain and sodium hydroxide is formed in the solution. Chlorine gas is liberated at the cathode. No. Why? Chlorine Cl minus gets attracted to the positive electrode where it undergoes oxidation. Oxidation, that is the positive electrode is the anode. So this is also incorrect because it says cathode here. Anode dissolves. No. Both the electrodes, there is gas bubbles evolving or liberated near both positive and negative electrodes. So this is also incorrect. So we need to find what happens when an aqueous solution of sodium chloride is electrolyzed using carbon electrodes. So that is the second answer. Sodium hydroxide is formed in the solution. Is that clear, student? So then, we will look at the next question. Question number 8. When a solution of copper sulfate is electrolyzed using carbon electrode. So this is another one. Copper sulfate using carbon electrodes. So we will try to understand that as well. Here, if we take electrolysis of copper sulfate, here also we have the carbon electrodes and the dry cells. So here, when they are connected, this is positive, negative, this becomes positive and negative. Now this is copper sulfate aqueous. That means Cu2 plus ions, sulfate ions and H plus ions from water and OH minus ions from water. Now out of these also, when you have copper and hydrogen, in the activity series you all know copper is below hydrogen. That is, copper is less reactive than hydrogen. So copper is the one that will undergo reduction. So here of course it's going to be copper that undergoes reduction. And out of the two negative ions, it is hydroxide ions that undergo oxidation. So what will happen there? It is near the positive electrode. Positive electrode, it is going to be OH minus ions undergoing oxidation to water molecules plus O2 gas losing 4 electrons. So this is anode. Why? Because oxidation takes place there. Then Near the negative electrode, it is going to be the copper ion, Cu2 plus, aqueous, taking up electrons and depositing as copper solid. So what are the observations? You will see gas bubbles liberated at the positive electrode, that is the anode, and red-brown color deposit at the cathode. Why? It is reduction. So there, negative electrode, there will be a brown color deposit. Now normally, copper sulfate, what is the color? It is blue in color. But from the copper sulfate solution, here you can see Cu2 plus aqueous is being used up during reduction. So the amount of copper sulfate in the solution will decrease. Because of that, what happens to the color? The color will decrease gradually. So the observations are, near the positive electrode, there is O2 gas bubbles liberated. At the negative electrode, you will see copper depositing. And you will see the blue color of the solution decreasing gradually. Those are the observations that you will get. And these are the reactions. So if we go back to the question there, you can see this. When a solution of copper sulfate is electrolyzed using carbon electrodes, copper is deposited on the cathode. That is correct. Copper is deposited on the cathode. Copper is deposited on the anode? No. Why? Cathode is where reduction takes place. So copper gets reduced. Near the anode, it is oxidation of OH minus ions. Oxygen gas bubbles are formed at the negative electrode. That is also wrong. Why? We saw that the OH minus ions, which are negative ions, go towards the positive electrode. So that is also wrong. The blue color of the solution remains unchanged. That is also incorrect. Why? I told you all, when copper is being deposited, copper ions are taken from the solution. So finally, you all know it will be H plus and SO4 minus that remain in the electrolytic cell. So that is colorless. So with time, the blue color of copper sulfate will decrease. So the correct thing that happens during electrolysis of aqueous copper sulfate is that copper deposit on the cathode. The rest of the statements are wrong or not. They do not occur here. They don't happen during electrolysis of aqueous copper sulfate solution. So I'm sure students, you all were also able to answer these questions correctly. With that, I'm going to move on to the next question. So then, question number 9. So here also you can see which of the following is not a conductor of electricity. So, not a conductor of electricity. What are conductors of electricity? Materials that allow electric current to pass easily through them are known as electric conductors or conductors of electricity. You all know usually metals are very good conductors of electricity. So if we look at the answers, in addition to that, metals are solids, liquids. When we say liquids or solutions, liquids of ionic compounds, fused or molten ionic compounds, or the solutions of ionic compounds are good conductors of electricity. Acids are good conductors of electricity. Bases are good conductors of electricity. They are all in the solution form. So you all are familiar with that. Aqueous sodium hydroxide, yes, there are mobile ions. So it does conduct electricity. Acidified water, yes. Water is a covalent compound. It ionizes a little bit, but still water doesn't conduct electricity well. But when you acidify it, due to the presence of sulfuric acid, usually we use sulfuric acid to acidify water, there are more mobile ions in water. Because of that, it is a good conductor of electricity. Solid sodium chloride. Now, in solid sodium chloride, that is NaCl solid, this is the ionic lattice. In ionic lattices, the point charges are all fixed. They cannot move. There are no mobile ions. So, because of that, solid sodium chloride does not conduct electricity. Aqueous sodium chloride? Yes. When you dissolve solid sodium chloride in water, they dissociate completely, forming Na plus aqueous and Cl minus aqueous. And there are a lot of mobile ions. Because of that, aqueous sodium chloride can conduct electricity well. So that means the answer to this question, which of the following is not a conductor of electricity? Solid sodium chloride. Then, during the electrolysis of acidulated water using carbon electrodes. So you have to remember that as well. Electrolysis of acidulated water using carbon electrodes. If we look at that process, you have the electrolytic cell here with acidulated water, the carbon electrodes and the power supply. So positive, negative, these become positive and negative. This is acidulated water. In acidulated water, what do we have? H plus, OH minus, H plus, SO4 2 minus. So out of these, H plus will undergo reduction, OH minus will undergo oxidation. Near the negative electrode, H plus ions will take up electrons, becoming H2 gas. So that is the reduction. And near the positive electrode, it is going to be OH minus ions losing electrons, becoming water to water liquid plus O2 gas, losing 4 electrons. That is the oxidation reaction. So here this is going to be O2 gas and here it is going to be H2 gas. And you can remember, there are 4 electrons here, there are only 2 electrons here. So to balance the equation, we need to multiply the reduction by 2. So therefore, the ratio between O2 and H2, O2 gas is to H2 gas is going to be 1:2. So 1 volume of oxygen, 2 volume of H2 gas. You can remember we use the different type of electrolytic cell where you have a plastic cup, the carbon electrodes inserted fixed into the plastic cup, and on top of the electrodes we have 2 test tubes filled with water inverted onto the kept on top of the electrode so that the gases get collected into that. And there you will see more hydrogen gets collected and less oxygen gets collected. You can remember all that. So then, if we look at the answers, what happens there? Hydrogen is evolved at the anode. No, because this is the cathode. So this is wrong. Oxygen is evolved at the cathode. That is also wrong. This is the anode. Oxygen is evolved at the anode. Hydroxide ions are generated at the anode. Now when we say generated, it's like it's being produced. That doesn't happen here, no students. When we use acidulated water, due to the presence of sulfuric acid, there are H plus ions, OH minus ions and sulfate ions in the medium. So they are not generated. So instead of this word generated, if the word has been oxidized. Now there is a small printing error, students. Because of that, there is no answer for this question. In this electrolytic cell, hydroxide ions are not generated. They are actually oxidized at the anode. This is of course correct. You can see this is oxidation at the anode where OH minus ions are oxidized. So then anode dissolves. Nothing like that happens in this electrolytic cell. So that is also incorrect. So if you look at the textbooks of the other mediums, there you will see the answer given, the third answer says oxidized. If it says hydroxide ions are oxidized at the anode, that is correct and that will be the answer to this question. But here, since they say generated, that does not happen there. So because of that, there is no answer for this question. You all have to understand that, student. So with that, I'll move on to the next question. The 11th question. Which of the following is an occasion where electrolysis is not used? Electrolysis is not used. Coating an iron spoon with nickel. Yes. Coating iron objects with nickel, even chromium, copper, all that is done using electrolytic processes. That is correct. Extraction of aluminium metal? Yes. Bauxite is the mineral. From bauxite, aluminium is extracted using electrolysis. That is also correct. Galvanizing iron nails. Now you can remember this. I have told you all this in the lesson also. When we say galvanizing, what do? They heat zinc to a high temperature so that zinc melts. And you have a tub of zinc and into that you submerge the iron objects. So there is no electrolysis process involved. You just submerge the iron nails into zinc so that the zinc coating will stick to the iron nails. So that is not an application using electrolysis. Then extraction of sodium from fused sodium chloride, that is correct. That is the downcell method of extracting sodium metal. So all these, coating an iron spoon with nickel, extraction of aluminium metal and extraction of sodium from fused sodium chloride, they use electrolysis in the industrial process. But galvanizing iron nails, that does not use electrolysis. So that is the answer to this question. Galvanizing iron nails. Is that clear, students? So then with that, I am going to end this chapter and in the next chapter, I will continue with the questions given in your textbook.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.